All right, we'll go and get started. If you haven't checked into On Campus, please do that. Uh, Today, I want to go over a couple of things. One, I want to review a little bit about what is on your screen right now. So this is just the arithmetic sequence, which we went over last class. Um, then I'll take any questions that people had over the IXL. And then after that, we will start to introduce geometric sequence. Okay, and kind of like arithmetic, we will find the nth term, and then we will find the sum. Right. So just a little bit of a review. Um, a sequence whose sequential terms have a common difference is called the arithmetic sequence. So the difference between every term is a constant number. All right, and that constant number we will denote as d, and we will call the common difference. All right, the nth term of an arithmetic sequence is always going to be the first term plus n minus 1 times the common difference. And then the sum of a finite arithmetic sequence is the number of terms we are adding together divided by 2 times the first term plus the nth term. All right, keep in mind here, this n is the number of things we're summing together. It's not necessarily the highest term of this sequence. Okay, it just has to do with the number of times we're actually summing things together. All right, and then on the bottom right, I have a little legend about what everything on a sum actually means. Okay, we should be okay on that, but just in case people need it, it's there for you. All right, so I want to take a second and just take any questions from IXL W11. It didn't seem like there were any, but I'll take another quick look. And while I'm doing that, make sure you have a notebook handy, and we'll get started right after that. Yeah, so I don't see very many questions on it. If you do, I'll be available after this in Teams. And if you have any more specific questions, you can ask me there. So that's arithmetic sequences. Again, it's just adding a certain term over and over again, which is a valuable kind of sequence to have. But we will actually be looking at geometric sequences just a little bit more when it comes to probability. All right. So a geometric sequence, instead of adding a term over and over again, we're going to be multiplying by a term over and over again. Okay, so a sequence whose sequential terms have a common ratio is geometric. All right. So if we have this sequence A1, A2, A3, and so on, it is geometric if the ratio between sequential terms is always constant. Okay, and I'll give people a little bit of time to write that down. But basically what this means is that A2 divided by A1 is equal to A3 divided by A2, which is equal to A4 divided by A3, which is equal to A5 divided by A4, and so on and so on. Each of those things are equal to a certain number, which we will call R, which is the common ratio. Okay, so we haven't actually found like the rule of the sequence or the sum of a sequence. Right now, we're just distinguishing whether or not something is geometric or not, which will be kind of your first goal on your homework tonight. Okay, so given a sequence, the first thing we should do is just to distinguish whether or not something is arithmetic or geometric, because those are the only two sequences we really know. All right. So in order to do that, we just follow this rule. We divide sequential terms and see if it's always constant. So in this first example, this 2, 4, 8, 16, 32, we need to see if that's geometric. Okay. So in order to do that, you would just take ratios of sequential terms. Right? So 4 divided by 2, 8 divided by 4, 16 divided by 8, and 32 divided by 16. Because each of these are equal, and this should be 8 divided by 4, because each of these are equal, we know we have a geometric sequence, and we know that our common ratio is 2. Okay, if those ratios weren't the same thing, then this sequence would not be geometric. Okay, and in that bottom equation, or that bottom sequence, we have negative 1/3, 1/9, negative 1 over 27, and 1 over 81. Right, and the same thing applies. We would take the ratio between two things. Right, so 1/9 divided by negative 1/3, negative 1 over 27 divided by 1/9, and 1 over 81 divided by negative 1 over 27. Okay, and even though there are a bunch of fractions involved here, we can still do this division. Okay, and if you feel a little bit wary about doing fractions within fractions, you can also just look at either the denominator or the numerator. Right, so if the numerator is changing, just look at the numerator. If the denominator is changing, just look at the denominator. So in this case, we're going from 3 to 9 to 27 to 81. But it's in the denominator. So we're going to end up getting, instead of just 3, 1/3. Okay, and if that's confusing, again, go back to the basics, take the ratios between each one. So in this case, we'll do 1/9 divided by negative 1/3, which when we're dividing by a fraction, we're really multiplying by its reciprocal. So this is actually equal to 1/9 times negative 3 over 1, which is negative 3/9, which is equal to negative 1/3. Okay, and we could do that for each one. Really, you do need to do it for each one, but just for the sake of time, I will tell you that they're all equal. And that's how you find out whether or not something is geometric. You find the ratio between two sequential terms, and if they're constant, then it's geometric. If any of the ratios are not equal to any of the others, then it's not geometric. Okay, so I want to pause there for a second. Are there any questions over what you see on your screen right now? Where did I get the 1/9? That's the second term in this equation, right? So it's 1/9 divided by negative 1/3. Negative 1 over 27 divided by 1/9. 1 over 81 divided by negative 1 over 27. So we're doing this rule. We're just replacing in what the second and first terms actually are. Just the fractions are confusing, but I get the process for the whole numbers. Okay, yeah, and this can be confusing, but if you remember that when you're dividing by a number, right, so in this case we're dividing by negative 1/3, we're really multiplying by that reciprocal. So instead of 1/9 divided by negative 1/3, we can do 1/9 times negative 3 over 1. Okay, and then from there we can just simplify. Now, you don't necessarily have to worry about that for tonight, but it's good to be able to see if something is geometric or not. Okay, so let's do some examples. Actually, let's not do some examples. The first thing we need to do is to actually find the nth term. Okay, so kind of like arithmetic sequences, we need to be able to find the nth term, and then we need to be able to sum things together. So in order to find the nth term of a geometric sequence, we take the first term times the common ratio to the power of n minus 1. Okay, and this equation, it's very, very important for geometric sequences. Okay, because that will always be whatever term you're looking for. So when you're doing these, this equation should definitely be in front of you. All right, so for example, I have two sequences here, so let's start with blue. In blue, we have 2, 4, 8, 16, 32. All right, so if we find our common ratio, which we did up above, we get r is equal to 2. Right? So in order to find the nth term of this sequence, we just follow that equation, right? So the nth term is going to be equal to our first term, which in this case is 2, times our common ratio, which is 2, to the power of n minus 1. And then that's it. Okay, so all this is doing is substituting in things that we know, and then that's our equation. Okay, in green, it's the same thing. All right, in this case, r is equal to negative 1/3. That doesn't change anything we do, though. So we still, if we're trying to find the nth term, we just take our first term, multiply that by our common ratio to the power of n minus 1. And then from either of those equations, you can get any term that you want to by just plugging in that number into the equation and getting an answer. All right. Are there questions about what I just did? All right. So what does this like mean? It doesn't necessarily mean a whole lot, but we can rewrite this using this equation in a little bit different of a way, which can help you maybe not necessarily right now, but when we get to probability. Okay, so if we take this sequence 2, 4, 8, 16, and 32, a good kind of way to think about this is in terms of our nth term equation. Okay, so we would write 2 as just our first term. We would write 4 as 2 times 2 to the first, 8 as 2 times 2 squared, 16 as 2 times 2 cubed, and 32 as 2 times 2 to the fourth. It didn't really change anything, but this explicitly has our common ratio and our first term in every one of those. And when we get to probability, this will actually kind of help us out just a little bit. So then we can do a couple of examples with this. And these examples kind of require us to know what a geometric sequence actually is. And from our geometric sequence, we know our nth term, which I'm actually going to copy down here. And we know that a geometric sequence is just multiplying something by the same term over and over again in order to get different terms of our equation. Okay, so in this example, in these two examples, or in the first one, it says find the first 5 terms of the geometric sequence whose first term is 3 and whose common ratio is 2. Okay, so this gives us the most important pieces of a geometric sequence, right? Our first term and our common ratio. Okay, so we can write everything we need from that. Right, so our first term is 3. Our second term then would be 3 times 2. Our third term would be 3 times 2 squared. Our fourth term would be 3 times 2 cubed. And our fifth term would be 3 times 2 to the fourth. And then we would just simplify that, right? So 2 to the fourth is 16. 16 times 3 then is 48. So 48 is our answer. Another way you can do it is just keep it simple, right? So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. And then 24 times 2 is 48. Questions about that example? Right, and we can be given, like pretty much like anything we've done in this class, we can be given different pieces of information. All right, so this second example, it says to find the 12th term of the geometric sequence given. All right, so it goes 5, 15, 45, and so on. Okay, so we have our A1. And for any geometric sequence, the first thing that we should ever find is R, really, our common ratio. Okay, and because we're given that it's geometric, all we really have to do is find the ratio of 2 sequential terms. So when we do that, we get 15 divided by 5, which is just going to be 3. Okay, and we can do the same thing for 45 and 15. It's going to be the same, right? So R in this case is just 3. And then we have everything we need to find any term in the sequence. Okay, given our equation up here. All right, so an, our nth term, and really we want to find the 12th term, is going to be equal to our first term times our common ratio to the power of the term we're trying to find minus 1. And then when we plug that into a calculator, we can get an answer. And when we do that, we get 885,735. Okay, and that would be the 12th term in this sequence. And again, I want to pause there for a second. Are there any questions over anything that I just did? And still, we can be given even less information. All right. So before we actually start this problem, I'm not expecting you to be able to do this like on your own just yet. Especially this problem. Like the other two, yes, you can do on your own. This problem is a little bit harder. Okay. Um, and right now, what I want you to understand is what a geometric sequence actually is. Okay. So a geometric sequence is just when we multiply by something over and over and over again. And just that simple concept can help us find the answer to this problem. Okay. So again, I'm going to have our equation up here. Okay. And this example says to find the fourth term, or sorry, the fourth term in the sequence is 125. So we are given A4. The 10th term is 125 divided by 64, so we're given A10. And we want to find the 14th term. And in any geometric sequence, the first thing that we need to do ever is to find the common ratio. Okay, and I want you to think just a minute about what a geometric sequence is actually saying and how we would get from the 4th term to the 10th term, and then from the 10th term to the 14th term. Okay, so remember, a geometric sequence is when we multiply by a term, some number, over and over again. Okay, so if we start at A4 and we have to get to A10, we have to multiply by some number a couple of times. And we have to multiply by that number six different times. Okay, so in order to go from the 4th term to the 10th term, we have to multiply by some number 6 times. Okay, so if we kind of put that into our equation, which again, this can be a little bit trickier, we can rewrite this equation with what we know. So our 10th term is going to be equal to our 4th term times our common ratio to the 6th power. And then we can substitute in what we know. So A10, that's 125 over 64, is equal to A4, which is 125, times our common ratio to the 6th power. Okay, I want to stop there for a second. Are there any questions about how I got to the 6th power, or how I got from A4 to A10. Right, and then from there, we need to solve for r. So in order to get r by itself, the first thing we have to do is divide by 125. So when we do that, we end up with 1 over 64 on the left-hand side. And that'll be equal to r to the 6th. And then there are a couple different ways that we can solve for this. So we need to solve for r. So you can either take the 6th root of both sides. You can take the log base 6 of both sides. Or if you just know your powers of 2 really well, you can get it that way. Okay, so I know, and right now I'm just going to look at the denominator because that's the only thing with a number in it. 2 to the 6th power is 64. Right, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Okay, so we can get to 1 over 64 by multiplying 2 by itself 6 different times. And because this 64 is in the denominator, our 2 is also going to be in the denominator. So r then is going to be equal to 1/2. Because 1/2 times itself 6 times is 1 over 64. And again, whatever way you're comfortable solving that, this part can be a little bit confusing as well. But any way that you know how, you can solve that. And from there, really our problem is mostly finished. Because once we have r, and we have some term before the 14th term, we can solve for that number. Okay, so if we're trying to solve for A14, we can use any of these values and the new value that we just found in order to get there. Okay, so I'll use A10. And we have to multiply by r. Four different times in order to go from the 10th term to the 14th term. So our exponent will be 4. And then we just substitute in what we know. And then we can plug that into a calculator and get a number. And when we do that, we get a decimal, and when we convert that decimal, we get 125 over 1024. Okay, so I understand that this problem can be a little bit more confusing. But if you understand the concepts of what a geometric sequence actually is, we can, for the most part, get to our answer. Right? So again, I want to stop here. Are there any questions about what you see on your screen? And I'll preface that this won't be your homework. This is a little bit tougher of a problem. I just wanted you to see like how we can move from a concept to solving this problem. All right, and then we'll move into what your homework is actually going to look like, which is going to be this, very basically. All right. So we're actually going to be finding the sums for our homework, right? And the sum of a finite geometric sequence is given by your boxed equation in white. All right. So the sum of any geometric sequence, of any finite geometric sequence, is going to be your first term times 1 minus your ratio to the nth power over 1 minus r. And there are a couple of things I want to point out here. And I'll kind of give people time to write that down real quick, and then I'll start talking again. So a couple of things I want to point out. The n here in this equation isn't necessarily this n. These two things can be different. So this n is your upper limit, right? It's when you stop summing. This n, though, isn't necessarily your upper limit. It's the number of terms you are summing together. Okay, so there is a difference there. So the n in your equation is the number of things you're actually adding together, right? So very basically what you'll see on your homework is something that like what you see in green. So you'll have the sum from 1 to 12 of 4 times 0.3 to the I minus 1. And we want to sum that together, right? And this should be easy so long as you can pull things out and put them into another equation, right? So in this case, we need A1. So A1 would be 4 times 0.3 to the 1 minus 1, which is, when you simplify that, it'll just be 0. Sorry, 4. Right? 0.3 to the 0 power, that's just 1. 1 times 4 is 4. And then our common ratio is this piece right here. It's 0.3. And then really we have all we need. So we just plug that into our equation. And then we can get a number. Which when you do that, you get 5.714. Okay, and that for the most part is your homework. Just plugging into that equation, right? And I want to, again, just address one more thing. Your first term isn't necessarily the first term in the sequence. Your first term is governed by your index and your lower limit. Okay, so if this were I equals 3, your first term would really be A3. Okay, so that's like the only thing people get tripped up with, right? So as long as you know that, and that this exponent is the number of terms you're summing, you should be okay. And they don't show up that much, but it's helpful to know those two things. Okay, so I'm going to stop there. We'll get to infinite geometric sequences next class, and then we'll move on from there. but I'll leave this open for a couple minutes. I'll answer any more general questions here. And then after that, if there are no questions, I'll start a meeting on Teams and I can answer a little bit more specific questions. Okay. And before people start to leave um, your exam, I'm still kind of deciding what I want that to look like. I have a pretty good idea of what my other classes will look like. Um, but right now we have like 4 or 5 more class days left. So I do want to like get into probability, which will take a class or two, and then I'll have some kind of project for you. Okay, it won't be a traditional exam. It won't be like you writing and then submitting it. I'll try and give you something a little bit more thoughtful. Okay. Um, so I will leave it up for questions for now, for the next minute or so, and then I will start a meeting on Teams. What's the difference between us and other classes? You guys are this is a senior class, so they like your exams will start for this class on like the second or third or something like that. In Denver, we'll talk a little bit later about what we want to do, but for seniors, this class is over in the next like week or so. Yes, the homework is IXL. It is W9. And this is distinguishing between arithmetic and geometric. And then W, I think 12. Yeah, it's 12. It should be in on campus right now. W12, which is uh, basically this example. Why is my mouse not working? Okay, I had the wrong time in for your homework, so it is up now, but it is W9 and W12. All right, so I will end this. I'll end this stream, and if you have more specific questions, I'll see you in Teams here in the next minute or two.